A TSBVI outreach tutorial. APH Graphic Aid for Mathematics, aka Graph Board, Part 5, Graphing a System of Linear Equations. Example, y equals 1/2 x plus 3, and y equals -2x plus 3. Presented by Susan Osterhaus, a Texas School for the Blind, and Visually Impaired Outreach Math Consultant.
Now we're going to go back to our coordinate plane again, and this time we're going to try to graph a system of equations. But this lazy teacher, as again, is going to go back to that. Remember that boundary line of y equals 1/2 x plus 3. So this is not, hasn't been connected yet. So I'm going to just actually, I think I am going to go ahead and connect it again, so everybody will be able to find that fairly well. And I think I've got enough push pins to do the rest of what I'm about to do. So I'm going to connect those push pins. Now, at the present time, what I've just graphed is y equals 1/2 x plus 3. And now I'm going to add to this, we're going to go ahead and graph what I call a system of equations. Now, in this case, this is a straight line, and now we're going to add a second straight line to this coordinate plane. And the one we're going to graph is y equals -2x plus 3. Again, I've made it pretty nice. I've started with the same y-intercept, but I said this is y equals -2x plus 3, so our slope is now -2. To write that as a fraction, you could write it as -2 over 1. And that would mean you'd have to go down 2, which is negative, and to the right 1, and we're going to have a push pin. And if you remember, we go down 2, and in this case, to the right 1, we're going to go down 2, and to the right 1. And our students would be going zipping along here. And you'll notice that this particular line is going to be doing something very different from the others. Now, up until this time, as you go from left to right, you would have been showing your students that this is a positive slope. From left to right, if it's going in an upward direction, that means it's a positive slope. So, I'm not going to do as many as my students would do. I think I may stop there. But then again, I would have them, this is going down into the fourth quadrant, but what happens up here? Again, they would have to think in reverse and go up 2, because +2 over -1 would be the same as -2 again. So up 2 and to the, let me see if I'm doing this right. Okay, up 2, which is positive, and to the left 1, which is negative. Up 2 and to the left 1. Up 2 and to the left 1. Up 2 to the left 1, and you'll notice, I hope, that this particular line from left to right is going in a downward direction, and therefore it has a negative slope, which goes right along with the -2, so that's kind of, that helps them understand that they have done that correctly. Okay, and we're going to go ahead and connect the dots, so to speak, with this, and what we've done is created we have two intersecting lines. If I had chosen differently, we could have had two equations that were parallel, two lines that were parallel, but I wanted them to intersect. And actually, when students are doing this, what they find out is that the solution to the system, which is where do these two lines cross, is right there at the y-intercept of 3. That point is known as 0, 3, or 0, 3. And that would be their solution set. In other words, this one point is in both graphs. It would be a solution for both of the lines that we have drawn. So again, so students have done this, and so they're feeling pretty good about themselves. And again, when I give these and when they're doing manual graphing, I really do try to pick that intersection point to be, quote, a nice point. And by that I mean integers. When you get into trying to find solutions that are not integers, graphing is not necessarily the best solution. There are other ways to solve systems, which include substitution, linear combination, using matrices, using Cramer's rule, using any type of graphing calculator. But for our purposes, since we're graphing manually today, we're going to try to pick points that have integers and are very nice, that are going to be somewhere with a nice intersection point on our graph board. Okay, so we have just now learned how to graph a system of equations. So that is pretty much what I wanted to show you for just now. And we'll move on to something else in just a little bit.
This video continues in the TSBVI Outreach Tutorial Series, APH Graphic Aid for Mathematics. Look for other videos by Susan Osterhaus on Math for the Blind and Visually Impaired. APH is American Printing House for the Blind. A TSBVI Outreach Distance Learning production. Executive producers, William Daugherty, Superintendent. Cyril Miller, Outreach Director. Outreach producers, Susan Osterhaus, Math Consultant. Mike Bicknell, Media Specialist. Texas School for the Blind and Visually Impaired Outreach Programs. 1100 West 45th Street, Austin, Texas 78756 USA. Telephone, 512-454-8631. Website, www.tsbvi.edu. Video copyright TSBVI 2009. All rights reserved.